Okay, we're going to look at the different conformations of ethane and butane, trying to visualize them with some molecular modeling software, looking at the relative energies of the different conformations and representing those different conformations as Newman projections. So here in this molecular modeling program, I've got ethane, C2H6, and I can imagine rotating this molecule around the carbon-carbon bond to generate a bunch of dihedral angles. So I've asked the computer to look at a bunch of dihedral angles. Here's the computer animating the different rotations of that carbon-carbon bond. And we could imagine asking this molecular modeling program to estimate the relative energies between each of these different possible conformations. And so if we were to look at the computer's work, we could see, let's try to move this molecule out of the way. Here we go. We can see that of all the different possible angles that the computer was looking at, it comes up with a range of relative energies represented in kilojoules per mole, from really high energies. Here's 11.25. If we scroll down through the different angles, we can get relatively low energies. Here's a negative 0.25. And it sort of goes up and down and up and down again. Okay, let's choose a couple of these and see what structures have the lowest energy and the highest energy. Here's our 11.25. When we click on that, we can see that the conformation that has that high energy looks to be a really eclipsed geometry, eclipsed conformation with torsional and steric strain between the eclipsed hydrogens that are lined up with each other on adjacent hydrogens. If we look at its alternate, here's a lowest energy I could see, a negative 0.25 kilojoules per mole. We get our nice staggered conformation where the hydrogens on adjacent carbons are as far away from each other as possible. Okay. Now let's remind ourselves how to represent these as Newman projections. So I'm going to go over here and draw this conformation that we see on the program right now. Remember, with Newman projections, we imagine that our carbon in the back is very big, our carbon in the front is relatively small, and for a staggered conformation, we're going to put the bonds on each of those carbons as far away from each other as possible. Now for ethane, all of these positions here are hydrogens, and we called this again a staggered conformation. If we look at the high energy, again, we can represent that with a Newman projection. In this case, we're going to put the bonds very close to each other on the Newman projection. And again, since this is ethane, at the end of each of these bonds is a hydrogen, and we get a much sort of uglier Newman projection, and we can think of this as an eclipsed conformation. Okay, now let's consider all these different energies and think about what sort of pattern is being formed as this carbon-carbon bond is being rotated. Let's imagine plotting the data from this spreadsheet, and what we can see is that as we alter the dihedral angle, we sort of alternate energies from low to high, low to high, low to high, with the high energies being the eclipsed, the low energies being staggered.